In this video, we're going to find the solution to this system of equations by graphing. In order to do that, we're going to graph each equation separately and then find where they cross. So let's start with this top equation. Negative 2x plus y equals negative 5. When we look at this, we can do this by plotting points or by finding the intercepts, but the easiest way is actually going to just be rearranging it into slope-intercept form, because the y can be solved for very quickly. In fact, all we'll have to do is add 2x to both sides. That gives us the equation y equals 2x minus 5. To graph this, we need to know both the y-intercept and the slope. The y-intercept comes from the number at the end, the negative 5. So we know that we have the point 0, negative 5, on our graph. We also know our slope is the number in front of the x, which in this case is 2, which we can write as 2 over 1, because that tells us then our rise over our run. So let's start by plotting our y-intercept at 0, negative 5. So from the center of my graph, I'm going to count down 5. 1, 2, 3, 4, 5. And because my slope is 2 over 1, I'm going to count up 2 and right 1. I do find it helpful to go ahead and do that a couple of times. So up 2, right 1, up 2, right 1, just to have a few additional points to work with. Now that I have those points, I'm going to connect them with a straight line. It is going to be really important that you're using graph paper when you're doing this, and that you're using a straight edge like a ruler. So make it as long as you can to go through the points, but still make sure that it is accurate. So then our other equation, we still need to plot it. So we have 4x plus y equals 1. To solve for y in this equation, we're going to subtract 4x to both sides. This gives us that y equals negative 4x plus 1. Because we have that plus 1 at the end, we know our y-intercept will be at 0, 1. The number in front of x is negative 4, so we can say our slope is negative 4 over 1. So let's start by plotting our y-intercept at 0, 1. From here, we're going to count down 4, 1, 2, 3, 4, and right 1. And again, I like to do that a couple of times. 1, 2, 3, 4 over 1, because then it just makes it a little bit easier to connect my dots. When I do that, again, being really careful that I'm being accurate, we can see that the two lines do cross, which means there is a solution. The point that they cross at is right here, and that is the point 1, negative 3. So 1, negative 3 is the solution to our system of equations, which means that it is a valid solution to each equation separately. We do recommend that you plug the point back in to each of the equations to double check to make sure everything is solid, but that is the final answer.